So in this video we are gonna prove a proposition. So proposition say that a non-decreasing function f from R to R is borel measurable. Okay, so to prove that a function is borel measurable if the inverse image of borel set is a borel set. Okay, that we know. So first we can see that let a belong to R. Okay, and we already know that what is this thing, but let's recall it. So it is nothing but it is the set values where function is greater than a. Now since f is not decreasing means f is increasing, so the function is gonna behave smoothly, like it's gonna be continuous or it's gonna be jump, it will have jump discontinuity. So because f is not decreasing, that is the function. So now if it is decreasing, and then we know that it's gonna be continuous or it's gonna have jump discontinuities. So suppose it's gonna we can see that by trying to better understand. So suppose if this is my a and this is my b, so suppose this is continuous, and then suppose now it has jump discontinuity. So we can have many type of jump discontinuity. So suppose it is a hole here, and so this is also another kind of jump discontinuity, and then we do have this jump discontinuity. Over here we have a hole, and over here we have this thing. Okay, and then so in this case this is b, so this is gonna be and this is gonna be. In this case we can see that okay, a value is this thing and this is my f of b, so a is lesser than f of b. Okay, that is kind of we can have. Okay, these are the situations that we are assuming that if the function is not decreasing and it will have continuous, it will be continuous, or it's gonna have jump discontinuity, but that kind of jump discontinuity. And over here it has both holes. So suppose this is my f of b value, and now this is that this a value is gonna be greater than f of b. Okay, so that's kind of we can imagine. Okay, so now let's prove. The proof is very easy. So we can say that let b is infimum of f is greater than a. Okay, so this f is greater than a is nothing but is this set represent the value of domain where the function is greater than a. Okay, so now we saw that. Okay, so we saw that in case of third. Okay, so over here we saw that a is equal to f of b. Okay, so in this case we already saw that in this case. So in this case we can see that, so assume we can see that a is equal to f of b. Suppose this. Okay, so if a is equal to f of b, what do we think about the value of the domain where function is greater than a? So definitely these will be the value. Okay, in this case if a is equal to b, these are the value of the domain where the function value is greater than a. Okay, so we saw that. So now, so if a is equal to b, then we saw that x belong to x, f of x is greater than a is nothing but b to infinity. Okay, and if a is lesser than f of b, then so we can go back again and we can see it. So if a is less than b, these are the value of the domain. Even you can see this b is also greater than a, so now we will include this b. So definitely we are gonna have that now this f is greater than a is nothing but b to infinity. And if a is greater than f of b, then again we can go back and we can see it. Okay, so we can see that if a is greater than b, so this is a is greater than b, then what are the value of the domain that are greater than a? So definitely b will not be included. Clearly you can see that by this figure. So again we will have the same kind of open set. So then f is greater than a is nothing but this is b to infinity. My drawing is not good, so you should draw proper figures, then you will understand, but I think I give you the idea. So in this case, in every case, in all cases f is greater than a is a borel set. Why? Because see, this is open, half open, half go, and they are coming from the borel set. Why? What is borel set? So borel set is an element of the sigma algebra generated by all the open sets. Okay, so hence we prove that it is a borel set. So f is borel measurable. Okay, and that's it. I hope you understand it. I try my best to do in a better way. Thank you.